Give me a sign. Let me sign.
Oh no, the peach tree is up on the orange tree. What are we gonna do? We could call and now I guess. Mathmaticus!
I just heard somebody call my name.
This looks like a job for Mathmaticus. Defender of truth, justice, and correct math problems everywhere.
Protractor boy, I got a hot case here and I need you and your class to help solve it. You have your costume ready this time? Good. And go ahead and put it on. Go ahead and pause me and we'll get to the project as soon as you're ready. Here we are in the backyard. We got this peach tree over here, leaning very heavily. And it's getting close to falling. And maybe it might hit this orange tree on my right. The owners of this house don't want that to happen. They love their precious orange tree. In order to solve this problem, we need to know two distances. We need to know the length of this peach tree from the base all the way to the peak right up here. The second thing we need to know is the distance from the base of this peach tree right here all the way across to the orange tree. Those are the two distances we're going to need.
Take a look at this drawing of the situation. The slant height of the peach tree is longer than the distance that the tree is from the orange tree.
Maybe so, but I'm going to take the measurements of the distances just to be sure. now that I've got the distance between the two trees, I'm going to walk away to the other side of the peach tree and measure a distance away from it so I can figure out the slant height of the actual peach tree. That may be the case. In this case, yes, I probably could measure the height of the tree by itself, but in many cases you'll see trees that are too big, much too big to measure. So I'm not going to be able to do that here. I'm going to show you how to do the measurements without having that advantage. That's a good question. I'm using string. It's going to help me when I do the angle measurements next. Maybe a little hard to see, but I've got my white string set up from the base to the peak and then away from the tree. Got the whole triangle set up so that I can figure out the slant height using this triangle. Now I'm going to need a protractor to measure my angles. This is where you come in, protractor boy. Can I get the protractor from you? Thanks. Wow, this is old school. Look at that. Let's see. Open it up. There's my protractor. Here we go. Take a look at the protractor.
Okay, put the crosshairs at the vertex. Now we look. Zero line looks good. It looks to be about 22.
Now I've got to measure the other angle. Again, putting the crosshairs right at the vertex of the angle. We look and we see the measurement is about 40 degrees on this side of the triangle. Okay, so let's go back to our picture. And we're going to fill in the data we just got from our measurements of the tree.
So now we have a drawing of the situation. We have put in the 105 inches between the trees, 77 inches on the other side of the peach tree. We have also added the 22-degree angle and the 40-degree angle. Now from just this information given, there is a way to find the height of our peach tree. Your task is to see if you can find it. You guys are a smart bunch. Go ahead and pause the video, let them see if they can figure it out themselves, and then unpause it when enough of them have figured it out. Now that you have time to find the answer for yourself, let's go over the solution. Your first step was to find all the angles inside the triangle. Once you do that, you'll find that the small angle on the upper part is 18 degrees. That's the important one. 140 is important too, but we're going to get rid of it when we draw in the altitude from that angle. Now we've created two right triangles. Right triangles. I know how to solve right triangles. For the right triangle on the right with a 22-degree angle, you will notice that the h is actually on the opposite side, giving me sine 22 is equal to h over 77, where 77 is the hypotenuse. Now if we go to the triangle on the left with the 18-degree angle, h is also part of its sine function, and the peach tree height is x, the hypotenuse. So then we get sine of 18 degrees is h over x. Both of these equations have an h in them, so we're going to rearrange the equations to solve for h. Sine of 18 is h over x. We multiply both sides by x, and you get x sine 18 is equal to h. On the right side, you take the 77, multiply it to the other side, and you get h is equal to sine of 22 times 77. Now that both equations are solved for h, we can set those two equal to each other. As if x sine of 18 is equal to h, and 77 sine of 22 is equal to h, then that means that x sine of 18 degrees is equal to 77 sine of 22. Now all we have to do is get x by itself. So we're going to divide both sides by sine of 18, and we get x is equal to 77 sine of 22 divided by sine of 18. Now that we have our x value, we just plug those numbers into the calculator, and we find that x is going to be 93.5. 3 inches. Let's go back to where we had x sine of 18 is equal to 77 sine of 22. Now we replace that 77 with little a and 18 degrees with angle A. We can also replace x with b and 22 degrees with angle B. Once I magically replace those, I get the equation b times sine of A is equal to a times sine of B. This is one way you might see the law of sines, but more commonly we see it in this format, where you have side of the angle divided by the side opposite is equal to sine of another angle divided by its side opposite, where sine A over A is equal to sine B over B. And that, ladies and gentlemen, is the wonderful law of sines.
Next time for sure.